I would like to invite Akanksha to moderate the panel discussion.
We will begin with the panel discussion immediately. Hence, I invite our speakers and I request our viewers to stay tuned and post their queries in the Q&A box so that we can take them up at the end of the panel discussion. Lately, India has witnessed a numerous building collapses incidents due to various factors. So, what are some prominent proactive maintenance strategies that we can implement to avoid such disasters? Yes, Rishabh, we should know your inputs.
First of all, like building collapse incidents to ensure the long-term structural integrity. So I believe the very first step is like always conduct a regular structural audit, or what we can say is a condition assessment more precisely. In a similar way, when we find the wrong things like in our structure, let's say we have seen the cracks or leakages, let's say the basic things, we always consult and we always get it timely repair and rehabilitate. Next is preventive maintenance program, use of high quality materials. The considered design load for the residential and for the commercial or let's say industrial is always different. So load management and monitoring also one of the important thing what I believe to avoid the collapse. Uh, let's say education and monitoring. So many association, good association like sir told American Concrete Institute India chapter or Indian Concrete Institutes, ISSC, PETA, IS, so many organizations are come together to educate, to train people, informing people about the importance of the failure and how to avoid it. Seismic retrofitting, like let's say if you're considering the Palghar region, initially you might have heard that in last 2-3 years, the place near Dhundalwadi, more than 100 tremors of earthquake people have faced. Earlier it was not that. So for the buildings in the seismic zone, retrofitting are also improve the earthquake resistance. Regular waterproofing or drainage management is also important. I believe like waterproofing, trust me, I always believe it's a water resistant, but the media and trademark is waterproof. So regular waterproofing, timely, periodically, and efficient drainage management is also a key task. All these things should be done in the compliance with the building codes. So I think these are the basic things one can avoid the collapse. In short, that's all I believe.
Thank you, Rishabh, for sharing your expertise. Rohit, would you like to add into what Rishabh has just said from a design perspective? What proactive practices are necessary?
Basically, as Sir said, basically we have to design buildings according. Basically, we have to make provisions for preventive. Basically, this is not water. Basically, we have to make them water resistant so that the corrosion is not happening later on. Like we generally what we do is in residential buildings where the water level is very high, we create a channel outside the building to get the water collected and channelize it properly so that that does not affect the building itself. So that's basically preventive measures has to be taken care of, and as Sir said that we need to also prevent the reinforcement to get corroded in the hilly or in the coastal areas, and that's how we can prevent that building to damage later on. Yeah.
Thank you, Rohit, for sharing your inputs. Yes, sir, please.
We as designers, basically we are one of the first touch points to the clients, and we need to be aware about all these aspects which Mr. Rushabh and Surendra sir has already spoken about. It needs to be conveyed to the client as well, so that these preventive measures can be taken care of while designing the buildings.
Thank you for your expertise. Moving on to my next question, Rishabh. So how can real-time structural health monitoring systems be integrated into the existing buildings to analyze and to provide early warnings to prevent future mishaps?
See, like structural health monitoring, it is one of the finest tool I believe if one can implement, then we can avoid the future accidents. But to understand the structural health monitoring is itself a big challenge, I believe. So first, determine the type and extent of monitoring is required. Then accordingly, we can do the tailor-made structural health monitoring for a particular project. It is not like that 1 + 1 = 2 always. So depending on the type of structure, depending on the area or requirement, we can do the tailor-made customized SHM solution. For this, we used to install, like in critical areas, we may install the sensors, especially in the beams column, or let's say junction or the substructure, where the structural failure is most likely to initiate. But of course, such sensors are susceptible to the environment as well, like they might be exposure or having the potential to resist the corrosion or water ingress. It should not like happen that in-house maintenance team, we have the facility management system. If you consider a big residential towers or big structures, they have the in-house facility management team. So we can integrate that SHM to the existing management teams so that they will routinely review the data which the SHM is finding or anomalies that can indicate the potential failures. Predictive maintenance planning will also help for the SHM. Real-time alerts or proper interpretation of the data which you are collecting through the devices. Construction or making devices is of course a big challenge. Installing it to the structure is again a big challenge. Collecting the data from the device is also a challenge. And the most important challenge is interpreting that data and taking the decision accordingly. That all four together, that chakra view, पहले वो device बनाओ, उसको install करो, so of course the actual weight I won't get. So the calibration of such sensors or such tools is utmost important for giving you the correct results. Cloud computing, many times it's a big data, it's a big data. So many times it's always rewrite. So analyzing data, collective data, and interpretation. And lastly, I would like to add, like all such things should be a beneficial comparing to the benefit to cost ratio analysis. Like it should not like happen. We are planning to install the SHM, and however the cost of SHM is more than the maintenance cost or the repair cost. So anything which we are planning to install, it must be a good enough as per the benefit cost ratio analysis.
Thank you for your inputs. Yeah, moving on to Manjrekar ji, what distinguishes the third generation corrosion inhibiting admixtures from earlier generation, and how does it specifically address the challenges in large repair and greenfield projects?
Methodology was to create a barrier between corrodable substance and corroding materials. For example, oxygen, chloride, water, these flue gases, pollution, all those things we are trying to create a barrier, and that barrier, as a statement, it is absolutely all right, but as a practical thing, it becomes on a large sites or even on smaller site, it becomes so difficult to make a fractureless, a pinhole-less structure, protection. And if that happens, like I mentioned, the law of corrosion, that it is inversely proportional to the diameter of the aperture, the whole thing fails. Whole thing absolutely fails. I am under impression that I have done a job. I am under impression that I have spent money, and ultimately the result that I get is something I'm not happy for anybody. What you need is user-friendly and high technology materials. It is high technology, rocket science, it's of no use. It should be a rocket which should be flown by ordinary man, ordinary person. And that is the case which happens in case of these uh, corrosion inhibiting admixture. And this is for India, it is around 10 years old story or something like that. But all over the world, it was found to be inevitable. And because it was found to be inevitable, right from 1940s, they started working, and big departments like Federal Highway of US and other NACA uh, corrosion bodies, they started working on that. And it is simply you have to add, and it creates automatically on thermodynamics nanomolecule layer. So that was the third generation difference. And you asked the meant that there is no option but to use this corrosion inhibiting admixture, and in that you have to make as many developments as you can, and that will continue to happen. uh, uh, Now large repairs, you must understand here again, that's why I said earlier that knowledge should be borrowed and learned and adopted by everybody from everywhere. When a repair happens, try to imagine a repair situation. When a repair happens, it is a patch repair. The entire structure to be repaired is called as reconstruction, and repair is a patch repair. Whenever patch repair happens, there is some steel which is untouched and some steel which was exposed due to corrosion. At the junction of corroded treated steel and untreated steel, later on there is a anodic ring, there is a potential difference. So that is why you may probably do one thing, that you can use this inhibiting admixtures and then eliminate that possibility.
Thank you, Manjrekar, for educating us on the various challenges that are faced in greenfield. Also to make us understand the differences. Rohit, my next question to you. So, what role does life cycle analysis play in your approach to maintain sustainable infrastructure? And how do you ensure that the both design and maintenance contribute to long-term sustainability?
Life cycle of a building, जैसे कि already said by sir that we have to be proactive from the start of the building itself. That on the design stage, we need to take care of all the preventive measures so that the building is not corroded or it is not damaged due to these inefficiencies which we were talking about. So, and later on, when the building is like, you need to mine the data of the previous buildings which have already been or gone through the phases, and with the devices, as sir already talked about, that we need to measure and take the preventive measures accordingly. And later on, when the impact is happening on the same, depending on the data, what previous buildings has gone through it, and we should take the steps so that that damage can be reverted.
Thank you, Rohit, for sharing your inputs. Rishabh, coming back to you, looking ahead, what innovative maintenance strategies should be adopted for future-proof buildings against the potential structural failures?
Of course, there are many innovative maintenance strategies. So I believe implementation of SHM can be innovative, and implementing predictive maintenance through AI. Like, right now what we are reading that SHM results, and then accordingly we are doing it repair and what. So like machine learning and AI will be the future in the future maintenance. Digital twin technology, you might be aware recently the digital utilization of the digital twin technologies can be used, but not for the but it for the skyscrapers, I believe. Then smart materials, or let's say the self-healing concrete. I still remember during my BTech, during my graduation in civil engineering, we have extracted the Bacillus pasteurii from the raw OPC cement, and we have uh, we have used that bacteria into the concrete, which have the self-healing properties. So whenever that bacteria comes in contact with the air and water, that precipitate the calcite. So they are having the uh, phenomenon of, let's say, the MICP, microbiologically induced calcite precipitation. So like this, smart concrete or self-healing concrete or smart materials will be the innovative maintenance practice for the repairs and rehabilitation. Then materials which are susceptible to the climatic change, like alternate wetting and drying process. So there will be a smart materials which will be the susceptible for the environment. Lifestyle assessment tools will now already incorporating in big industries. So that can be the automotive maintenance tool. So repeatedly one will fix the target life or target time for the particular repair. So let's say if you talk about the offshore industry, they are always do the anti-corrosive coating throughout their on period. So the automotive maintenance period can be done. So the augmented reality which and the robo can be efficiently used where the human cannot go in such areas. But still, I believe one can always go for the routine and periodic basic maintenance system. That also can help a lot.
Thank you, Rishabh, for explaining it so well. Moving on to my next question, Manjrekar ji. So, how does the admixtures align with the global sustainable goals, particularly in reducing the environmental impact?
I talked about 4% losses, but I must also bring out some facts over here. This corrosion or the steel industry is the biggest carbon dioxide emitter of all the industries. That is about 23%. 23% of global industries, 100% of global industry, the 23% CO2 is emitted only by steel industry. And if you take holistically all CO2, then it comes to 10% per annum. 10% per annum is a whole lot of CO2. Paris Agreement says 55% reduction in carbon dioxide generation up to 2030 from 1990 level. We are in fact going more than that. And there is no way to just control this. I think this is where this corrosion, all overall corrosion inhibiting admixture, because today I talked about corrosion inhibiting admixture, but when you take the entire range of corrosion inhibition, gamut of corrosion inhibition, that's a bigger subject. But that's how the corrosion is important, and this should be emphasized in everybody's mind. One takeaway from this session: if corrosion is such a bad thing, such a bad enemy of the mankind, that is more than anything, I think.
Thank you, Manjrekar ji, for your expertise and the way you have made us understand. It shows a depth of knowledge, and I'm sure our audience are quite captivated by your answer. Moving on to Rohit. So, from an architectural perspective, how architects can, during the designing phase, what kind of strategies can be implemented for more effective maintenance and to sustain the life of a building?
Each and every part of the building which is preventing water to get into the building needs to be taken care of in the designing stage. Like earlier, we used to use using chhajjas to protect the windows and preventing the water to get into the building. So these small things like water spout that coming out of the building and drainage system were properly planned from the age-old era. So we can take care of all new techniques which have already been in place for water to get into the building. We need to take care of the concrete admixtures and other things which we can definitely make the lifespan of a building a little longer than usual.
Thank you. With this, we have come to the closing of today's panel discussion. Indeed, it was an intriguing discussion. Thank you, panelists, for your contribution. I request Astha to conclude this session.
Thank you, panelists, for your valuable submission on proactive maintenance practices and structural excellence. We hope you have enjoyed it. Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Rushabh Surendra Karnavat, Dr. Surendra Manjrekar, Mr. Rohit Garg, and Alok Ranjan. For attendees who have joined us today, we would like your feedback and encourage you to stay connected with us via our social media handles. AC Update is available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. We request our attendees to stay tuned for future interactions. With this, today's interaction has now come to a close. Thank you and goodbye.